Assalamualaikum and hi everyone. In this video, we will explain the differences between capacitor and battery in terms of theory and principle, design, technology development, application, and the similarities. Before I start, my group members are Muhammad Yusuf Wazien, Azia Alina, and me myself Adilah. Firstly, the differences between capacitor and battery based on theory and principle. For battery, it is a device that stores chemical energy and converts it to electrical energy. The chemical reactions in a battery involve the flow of electrons from one material to another through an external circuit. The flow of electrons provides an electric current that can be used to do work. To balance the flow of electrons, charged ions also flow through an electrolyte solution that is in contact with both electrodes. And different electrodes and electrolytes produce different chemical reactions that affect how the battery works, how much energy it can store, and its voltage. Next, theory and principle of capacitor. A capacitor is a device capable of storing energy in a form of an electric charge. It is made of two parallel conducting plates separated by a dielectric that is a parallel plate capacitor. Compared to a same-sized battery, a capacitor can store a much smaller amount of energy, which is around 10,000 times smaller, but useful enough for so many circuit designs. The higher the value of capacitance, the more charge the capacitor can store. The larger the area of the plates, or the smaller their separation, the more charge the capacitor can store. And lastly, a capacitor is said to be fully charged when the voltage across its plates equals the supply voltage.
Next, I will explain the difference between capacitor and battery based on the design. A capacitor can be found in many forms such as cylindrical or sphere, but the most common and easy to find is cylindrical capacitor based on what it is used for. The basic capacitor is made up of two or more parallel conductive metal plates that are not connected or touching, as we can observe from the picture, but they are electrically separated by air or other good insulating materials such as wax paper, mica, ceramic, plastic, and some form of liquid gel as used in electrolytic capacitor. On the other hand, a battery can also be found in many forms such as cylindrical, rectangular, or flat spherical batteries that are usually used in watches. An anode, a cathode, and an electrolyte are the three essential components of a battery. If the electrolyte is insufficient, a separator is frequently known to protect the anode and cathode from touching. Batteries normally have some form of casing to store these components. Let's move on to the difference between capacitor and battery based on technology development. For capacitor, Von Cleese built the first practical capacitor. He took a medical bottle and filled it partly with water, as we can see from the picture, and then sealed it well with a cork. Later, he pushed a nail through the cork into the water. When Von Cleese was about to touch the nail, he felt the separated charges were able to reunite by flowing through his body. And then, Michael Faraday added his contribution as he came up with the concept of dielectric constant. He not only invented the first practical fixed capacitor and variable capacitor, but also the first usable capacitor, which was made from large oil barrels. Fast forward to 2000s, in MLCC, which is a ceramic capacitor for example, the technology is moving forward at such a pace that between 1993 and 2019, vendors were able to increase capacitance value per cubic centimeter of material from 1.0 microfarad to 1000 microfarads. It represents a remarkable technological achievement that has only a few global suppliers who can actually produce such devices. Moving on to technology development in battery, The first true battery was invented by the Italian physicist Alessandro Volta. Then one of the most enduring batteries, the lead-acid battery, was invented in 1859 and is still the technology used to start most internal combustion engine cars today. Battery can be improved these days by using lithium-ion batteries. Lithium is one of the lightest elements in the periodic table and it has one of the largest electrochemical potentials. Therefore, this combination produces some of the highest possible voltage in the most compact and lightest volumes. And then we have nanotechnology. Depending on the transition metal used in the lithium-ion battery, the cell can have a higher capacity but can be more reactive and susceptible to a phenomenon known as thermal runaway. In the 1990s, John Goodenough made a huge leap in battery technology by introducing a stable lithium-ion cathode based on lithium iron and phosphate.
Bismillahirrahmanirrahim. I am Yusuf and I will present the difference between the capacitor and battery based on the application. So, the application of capacitor. Energy storage device. Capacitor can store energy but not so much, providing only enough power for the electronical devices to use during temporary power outage. The next one is power conditioning. Capacitors allow AC signal to pass but block DC signals when they are charged, converting the current of AC to DC. Next one is sensors. Capacitor also can use to measure a variety of things such as the temperature or the humidity of the environment. The capacitance of device is dependent on its structure. The next one, capacitor also can be used to signal processing. DRAM, the dynamic random access memory devices, use capacitors to represent binary information as bits. CCD, also known as charge coupled devices, also use capacitors in an analog forms. So the next one is the application of battery. The battery is used in home, such as the use in the appliance at home, such as the hair trimmers, blenders, and mixers, camera, and much more. Next one is medical environment. Battery is also used in the insulin pumps, ECG monitor also use battery. In the firefighting and emergency responses also use battery. They use it to communicate with each other using the radio. The radio use the battery. Next one, military operation also use radio to communicate with each other, also use battery. And the last one is battery used in vehicles. The battery used in vehicles, EVV, electric EVV, electric vehicle battery, also use battery. Commonly, the battery is used to power the electric motor in the electric vehicles. Okay. The next one is based on similarities. The similarity of capacitor and battery. Both are capable of storing electrical energy, but the capacitor only can store the battery can store much more than the capacitor. Both the second one is both has series of resistance, and the last one is both can produce potential difference across any electrical component connected to them. So that's all from me and my friends. Thank you.